There are places in the universe that defy our language. Worlds so alien, so hostile, that our words for beauty and terror become one and the same. We find them by accident. A flicker of light in the darkness, a dip in the brightness of a distant star, a signal that tells us something is there, something we don't yet understand. On October 5, 2005, an astronomer named Frank Bouchy was reviewing transit data at the Haute-Provence Observatory in France, when a signal appeared that made him stop. It was the kind of signal astronomers spend their careers hoping to see, a perfectly regular, repeating dip in a star's light, the unmistakable signature of a world passing in front of its sun, a planet, orbiting a dim orange star 64 light-years from Earth, a K-type star, smaller and cooler than our own sun, but no less powerful to a world in its immediate grasp. The data was clean, the detection unambiguous. A new world had been entered into our catalog. He noted its coordinates. And weeks later, when the Hubble Space Telescope captured its color for the first time, the word that appeared in the scientific literature was one that planetary scientists almost never use. They are trained in the language of data, of spectra and albedo. But faced with this image, their professional vocabulary failed them. Beautiful. The most vivid electric blue ever recorded on an exoplanet. A blue so deep and pure it seemed impossible. It wasn't the gentle marbled blue of Earth, swirled with the white of water clouds. This was a solid, piercing, uniform cobalt, a color that seemed to radiate its own light from across the interstellar void. The planet was named HD 1897333b. That blue is not water. It is not sky. It is not the reflected light from a vast, placid ocean. The color blue on our world is a promise of life, of tranquility. Here, it is a warning. The beautiful color is a mask for one of the most violent environments we have ever discovered. It is glass, molten glass, falling sideways. At 5,400 miles per hour, HD 1897333b orbits its star 30 times closer than Earth orbits the Sun. 1 year lasts 2.2 Earth days. It is a class of planet we call a hot Jupiter, a gas giant that has migrated perilously close to its parent star, locked in a gravitational death grip. Its entire existence is a frantic, searingly fast race around its sun. It is tidally locked. One face always toward the star, one face always away. This creates an eternal day and an eternal night, a planet permanently divided between two extremes. But on this world, the extremes are not what you might think. The day side, 1,000 degrees Celsius. The night side, 700 degrees Celsius. The coldest place on this planet melts aluminum. The 300-degree difference between the two hemispheres is not a sign of relief, but the engine of a storm that engulfs the entire world. There is no night. There is no cold. There is only the blistering inferno of the day side, and the slightly less blistering inferno of the night side, separated by a perpetual twilight zone where the winds are born. The winds reach 5,400 miles per hour, 7 times the speed of sound, the fastest ever measured, anywhere. This isn't a weather system. It is the planet's entire atmosphere, moving as a single global hurricane, endlessly circulating heat from the day side to the night side in a futile attempt to find equilibrium. And those winds carry something. The clouds are silicate particles, fragments of rock and mineral, the same family as quartz, as sand, as glass. On Earth, these are the solid, stable materials that form our beaches and mountains. In the crushing heat of HD 189733b, they are the ingredients for rain. At 1000 degrees, silicate melts into liquid droplets, tiny beads of molten glass, glowing with their own internal heat. This is the source of the planet's impossible blue. The glass droplets scatter blue light more effectively than other colors, painting the entire world in a beautiful, deceptive hue. In a calm atmosphere, they would fall down. Pulled by gravity, they would descend as a gentle, glowing rain, settling into a sea of liquid glass on a surface we cannot imagine. There is no calm atmosphere on HD 189733b. Everything moves sideways, billions of molten glass droplets at 5,400 miles per hour, each one the speed of a rifle round. This is not rain, it is a perpetual horizontal sandblasting, a storm of microscopic superheated bullets that shreds everything in its path, except liquid. The Venera probes, the most armored spacecraft ever built, would not survive a single second here. They were designed to withstand the crushing pressure and heat of Venus, but they would be flayed to atoms by this sideways glass storm before the heat or pressure could even register. We have never sent anything to HD 189733b. We have never touched it. We never will. It exists in a realm of physics so extreme that it is, for all practical purposes, a mythical beast. We can see it, we can measure it, but we can never visit. It is a world forever beyond our reach, a blue marble of pure violence. In July 2024, the James Webb Space Telescope pointed at HD 189733b. Its powerful infrared eyes were designed to peer into the atmospheres of such worlds, to dissect the light that passes through them and reveal their chemical secrets. They found water vapor. Expected. Carbon dioxide. Expected. In the superheated atmosphere of a gas giant, these are common molecules. Their presence confirmed our models, but told us little new about this specific world. Then, something they weren't looking for. A faint but distinct absorption line in the spectrum. An anomaly. A chemical fingerprint that didn't belong. Hydrogen sulfide. The compound responsible for the smell of rotten eggs. A gas we associate with volcanic vents and decaying organic matter. Its presence was a shock, suggesting a complex and active chemistry in the planet's atmosphere that we had not predicted. HD 189733b, already raining molten glass at 5,400 miles per hour, also smells like rotten eggs. The universe has a dark sense of humor. It presents us with a vision of sublime beauty, then informs us that it is a hellscape of unimaginable violence that also carries the foulest of odors. In 2005, we found it. In 2013, we confirmed the glass rain. In 2024, we found the hydrogen sulfide. A timeline of discovery, each step revealing a new layer of impossibility. Every time we look more carefully, it gives us something we didn't expect. It reminds us that our models of the cosmos are just sketches, and the reality is always stranger, more complex, and more wonderful than we can imagine. Imagine approaching HD 189733b from a safe distance, crossing the 64 light-years of empty space, watching as a dim orange star grows brighter, and a tiny pinprick of blue resolves into a sphere. From far away, the most beautiful planet you have ever seen, cobalt blue, vivid, absolute, like Earth from the moon. But where Earth's blue is a living, breathing thing, a mix of ocean and atmosphere, this blue is monolithic, unchanging, a perfect, terrible jewel. You move closer. Now you can see the Terminator line, the boundary between permanent day and permanent night. Not gradual like Earth's, a seam, a hard, sharp edge where the day side's incandescent glow meets the deep, starless shadow of the night side. It is a scar across the face of the world. Closer. Now you can see what the blue actually is. The color begins to resolve. It is not a surface. It is not a gas. It is a texture, a motion, a storm made visible, not an ocean. The entire disk is raining. Horizontal. Billions of droplets at 5,400 miles per hour. You can see the streaks now, the sheer velocity made manifest. A global, unending barrage of liquid glass, sweeping across the planet in a blur of motion. You would not feel the first cut. You would not feel any of them. Before your nerve endings could even fire a signal of pain, you would be gone, disintegrated, scoured into a cloud of atoms and swept away by the supersonic wind. We have never seen the surface. We may never see the surface. Does it even have one? Or is it just layers of increasingly dense, hot gas, eventually transitioning into a core of exotic matter under unimaginable pressure? The glass rain is born in the upper atmosphere, and it falls, sideways, into a deeper abyss we can only guess at. The name HD 189733b is not a name. It is a catalog number, a coordinate designation. It is the cold, sterile language of inventory. It says, here is an object, at this location in the sky, found in the Henry Draper catalog. We gave it a number because that is what you give something when you find it before you understand it. It is a placeholder for knowledge, a label for a mystery. 19 years later, we still don't fully understand it. The glass rain is real. The winds are real. The hydrogen sulfide is real. The cobalt blue that has no business being that vivid is real. Each fact is a piece of a puzzle that becomes more monstrous and more magnificent with every new addition. We have names for each of these things. We have supersonic wind, silicate condensation, Rayleigh scattering, hydrogen sulfide. But the names are not explanations. They are descriptions. They tell us is happening, but they fall short of explaining it all comes together in this specific, terrifying, beautiful way. Frank Bouchy found it in 2005 while reviewing routine data. He was looking for patterns, for the quiet, orderly rhythm of planetary motion, a signal that made him stop, a signal that pointed to a place of cosmic chaos, a world that breaks all our terrestrial rules of weather and chemistry. 64 light-years away, a planet is raining molten glass sideways, and every time we look more carefully, it gives us something we weren't expecting. It is a constant source of surprise, a reminder that the universe is not obligated to make sense to us. We named it with a number because we hadn't yet earned the right to name it with a word. A real name implies intimacy, understanding. A name like Mars, or Venus, or Jupiter. We still haven't.